My name's Joe Pearce, and I work in the Hydroinformatics team at Jacobs. And as part of my role, I'm the lead developer of the Flood Modeler API, which is what we're going to talk about today. So just a quick agenda of what I'm going to go through. I noticed on the polls that the majority of people were in the bucket of they've heard of the API but never used it. So hopefully this presentation will be very useful for you. I'm going to start with a refresher on the Flood Modeler API and what it is and what it does. I'm going to give a bit of information on sort of how it's packaged and distributed, which I think will be quite interesting to hear. Also some insights into its usage and adoption. Then I'm going to highlight some example use cases we've seen on projects. If there's time, I'll give a quick demonstration of how you can get started as someone who's never touched the Flood Modeler API before, or even has never touched Python before, to hopefully put you in a position where you feel confident to give it a go. And we'll finish off on some questions. So again, as Ollie said, as you think of questions, just pop them in the box now. So if anyone's seen me talk about the API before, you'll probably have seen this slide, but it's always very useful. So in a nutshell, Flood Modeler API is a free and open source Python package that provides a bridge between Flood Modeler and the Python programming language. And with this, it allows us to extend the capabilities of what we can do with Flood Modeler. So as a software, Flood Modeler on its own is sort of closed off from being able to integrate lots of external tools. So there's a lot of functionality within the existing UI, but if you're wanting to do any kind of processing or analysis with tools outside of it, often there's a bit of friction in terms of exporting data into different formats, or even then importing data from different formats back into Flood Modeler. So where the Flood Modeler API sits in, it is that bridge that gives programmatic interaction between Python and Flood Modeler. So with this, it allows us to write any code in Python that can interact with Flood Modeler's data types, but also in turn, because Python is very widely integrated into the wider data science ecosystem, it means we can also bridge it across to all sorts of other tools and technologies. So whether that's other Python libraries for data analysis or machine learning, it could be sort of database softwares, it could be plotting libraries, cloud computing platforms, all of that stuff that you can access with Python, you'll be able to then work through with the Flood Modeler API as well. So I'm sure you're all now thinking, but what does it actually do? So it's difficult to give an exact definition for this because it is essentially a Python library. What it does is just up to you what you want it to do and what you can build. But to put it into some broad categories of the kind of things you can do, firstly, working with model files, being able to read, edit, and update them. So whether this is DAT files, IEDs, IEFs, etc. Through the API, you're able to sort of read the data that's in there programmatically with Python. So for example, it allows you to summarize like cross-section properties, or if you wanted to output a log of all your structures in a DAT file and sort of automate that process, you can do that. But as well as just reading the data, you're able to edit existing data. So if you're wanting to edit roughness values or distance to next or any other cross-section properties, and also update them in terms of adding or removing things. So for example, if you wanted to add a whole bunch of new units based on survey, or if you wanted to create new IEFs to generate sensitivity tests, or routines for QAing models, all of these kind of things fit into that first bucket of being able to sort of read and update the model files themselves. We're also able to execute 1D and 2D simulations directly from Python, and be able to sort of process the logs and diagnostic information from Python as well. So whether this is to batch simulations and track the progress in a dashboard or a web app, or it could be that you're wanting to sort of bolt on some post-processing. So not only running the simulations, but say you've got a whole workflow of how you want to analyze that data and sort of build a report, you can sort of build those workflows with Python, which leads us on to sort of the third broad category, which is looking at the 1D binary results. So for example, the ZZN or ZZX files, with Python and the API, we're able to rapidly read these results and produce any kind of custom outputs, whether that's plots or sort of taking it further into different packages for doing analysis on the results, whether it's some statistics or machine learning, that sort of thing. And we can also work with the Hydrology Plus project exports with the API. So for example, to generate a bunch of simulations based on that Hydrology Plus export. But that still doesn't cover what all the things it can do, because once we start to combine these different components together, and then also start to combine them with other Python libraries and beyond, so other technologies that we can integrate Python with, it really does give you sort of endless functionality of what you can do. So you probably heard at the start of the presentation, I mentioned this is a free and open source package. So I just want to give a bit of info on why it's open source and what that means. So firstly, it allows for much simpler and direct distribution to users. So because it's a Python library, it means we can push it out via sort of the typical Python Rails. So that's, for example, installing it via pip, which gives a lot lower friction for a user to install and use it. And it means that as a user, you can run it locally on your own computer. You can run it locally if you're not connected to the internet, for example. You don't need access to the Flood Modeler license specifically to use the API. You can install the API into a container running in the cloud. You can install it anywhere you want that you can install normal Python libraries. It also will encourage innovation. So because you have not only the API itself, you also have the source code. So as a user, you're free to experiment with it, build anything you want. You can even go into the code yourself and patch in things that you want to add that aren't in there. So if there's functionality you want it to be in there, you can actually just go in the code and add it yourself, and even share that with your team. And finally, it improves the overall sort of Flood Modeler product. So ultimately, the reason you'll be using the Flood Modeler API is because you're working with Flood Modeler. So it just adds another tool to the existing sort of things you can do in Flood Modeler as a product. So the next couple of slides, I just want to go through a little bit about how it's packaged and distributed. So firstly, GitHub, we use GitHub for storing the code. We use it for all the normal things you would in terms of source control. So for example, when we're developing new features or fixing things or making requests for new features or logging issues, all of that is publicly available on the GitHub. So if you're a Python enthusiast who wants to learn a bit more about how it's built, you can go in and get involved yourself and see. You can raise bugs yourself, or you can suggest features and see how they get developed. But we also use GitHub for some other things, such as the automated pipelines that you can do. So anytime we make any changes, we have a set of automated checks that run. And then lastly, with GitHub, there's a functionality called GitHub codespaces. So this is something we encourage anyone who's like quite new to Python or to the API to look into, as it allows you to open up a fully featured web development interface that means you can start working with the API in literally one click. So on the GitHub page, you can just click open in GitHub Codespaces, and it will, without having to install Python onto your local laptop, or without having to install Git or all sorts of other complexities in setting up your own local environment, you can just click one button and start using it straight away. So in terms of how it's distributed, so we use the Python package index, or PyPy, and this is pretty much the way that every Python library is distributed these days. So it means you can install it simply with pip as you would any other Python package. And it also makes it very simple for updating to the latest changes. And lastly, we also put out some documentation for it. So at api.floodmodeler.com, you'll see a getting started guide, as well as a more detailed user guide, as well as details on release notes. So all of the information you might need about how to use it should be in here. So this is just a quick slide on sort of the adoption and the usage that we've seen so far. So as it's a Python library, that's the way that it's distributed, it's very difficult to really capture adoption directly, but there are ways that we can indirectly look at it. So one of the things we look at is what I'd call sort of unique user downloads. So as you can see on this graph, the API has actually been out for a couple of years now, and up until sort of the end of last year, we had relatively steady uptake in these unique user downloads, but in the sort of the last 6 months from the start of 2025, we've had a much sharper increase in adoption, which is really great to see. Another sort of indirect marker that I see that I'm hearing a lot more about people using it for interesting things. I'm particularly find it really interesting when I hear about people using it in ways that I wouldn't have actually ever assumed someone would use it for. So that's always good to hear. And also we've now got had 16 contributors on GitHub, and this includes people outside of Jacobs as well as internally. So that's great to see. So I just want to go through a couple of project examples of how it's been used. I imagine when you see the more abstract use cases that I talked about before of the things you could do, it's sometimes hard to visualize what that might actually look like on a project. So hopefully these slides will give you a bit of inspiration for how you can actually apply it on a real project. So the first example is actually a project that was done by ACOM and presented at the Flood Modeler conference last year. And this was showcasing how they'd use the API to calculate siltation in cross sections. So this was for a very large model, and without being able to automate it, this would have been a very time-consuming sort of manual effort to basically export cross-section data to and from Excel. But with the API, they were able to read in all the cross-section data and also automate the process of applying that siltation in like a more sort of real way. So rather than just a really simplistic approach of just adding a flat minimum level, they were able to develop like quite a unique way of adding siltation automatically. So not only would this help on the first sort of run of it, of updating the model once, but because that code's been generated, it means if there's then further updates to the model and it needs to be run again, it can just be run again. And again, if they want to take that code and apply it on different projects as well that may want to do a similar sort of thing with siltation, it means that those benefits can be leveraged from the first time it was developed. Some other examples are some automated QA checks that we've developed internally at Jacobs. So using the API to sort of improve the quality and efficiency of checking models and avoiding the need for only looking at spot checks. So we're able to check much more thoroughly. So just some examples of these is one of them looking for spikes in cross-section conveyance. So with the API, you're able to basically iterate through every cross-section, have a look at the conveyance plot, and in this example, we actually create a plot of the conveyance for every cross-section, highlighting up the points where there's these negative spikes. And we could even take it a step further and in the API itself, automate the process of adding panel markers at those levels. And so as a reviewer, we can see the sort of the before and after of the conveyance curve, and it still gives the reviewer the chance to actually decide whether or not they do want to have those panel markers added. Another one of these QA checks looks at comparing the differences in 1D and 2D widths. So we can use the API to calculate that 1D active or full cross-section width. And this is a good example of where we then combining it with other Python libraries. So for in this case, also combining it with some of the geospatial libraries available to be able to calculate that 2D width as well between bank lines. And again, instead of having to rely on spot checks, as a reviewer, you can actually have a table of every single node and what the 1D and 2D width is. And the last sort of project example is more on the sort of plotting of results. So although in Flood Modeler itself, you can, of course, go into your results and plot them and do all sorts of things with that. With the API, you've got sort of a lot more configurability, so you can plot results. Say if you're running lots of different scenarios, in this case, it's looking at reservoir, how sort of reservoir gate operations impact water levels further downstream. And if you're running lots of simulations and you've got sort of almost like a template of what you want your plots to look like, it can be really useful for removing that time-consuming method of having to create them each time, especially if there's then multiple iterations that would have to be then just repeated work. And with Python, there's a huge amount of available libraries for plotting. This example is just using matplotlib, which is a pretty standard one for most plots, but you can also use some libraries such as Plotly, which allow you to do sort of more interactive plots or animations or things like that, which would be really useful. So the next thing I want to just show, in terms of getting started as someone who's new, the documentation is a great place to start, but what we've created recently, which is an even better place to start, and it's maybe worth bookmarking as well if you're going to be using the API, is the new Flood Modeler API on a page. And I'll just show you what this looks like. So if we open it up here, you'll be able to find it at the link above, and we'll share this link out as well after the webinar. But essentially, this is a great place to have all of the sort of information that you'll need at your fingertips. So firstly, how to get started with a link to the codespaces, how to install it locally, links to the documentation, a bit of an overview of each of the sort of core classes of what they do, and some more information, how to get involved. And then also we have this cheat sheet as well, which gives you lots of different snippets of code that you may want to use as inspiration. So for example, if you're wanting to look at updating Manning's values in a cross section, you can see here there's a little snippet, and you can click on these, copy and paste them of the code. So some are really simple, just like how to read a DAT file. Others sort of a bit more complicated. So like, for example, how to plot similar plots to I showed before, where you have the cross-section profile and the conveyance curve. So yeah, we'll send the link out to this after as well. And then in the next minute, I'll just do a very quick, just show you the GitHub codespaces that I was talking about before. So this is something where, as I said, you can access this in one click on the GitHub page, just using this open in GitHub codespaces. And when you open this, it will take you to something that looks like this. So it's actually a fully featured development environment. But you'll first be guided to this getting started notebook that we've got. So if you're completely new to Python, this would be a really good place to start, as you can you get a bit of an introduction to Python. It lets you like try out bits of code and run them like this, and you can go in and edit them as well, and just get a feel for sort of working with Python. If you have got through that, or you're already comfortable with the very basics of Python, if you carry on further down, it will give you a sort of a primer on the basics of using Flood Modeler API, and again allow you to sort of run things interactively within this notebook. So if it's loading a DAT file, having a look at some, in this case, the general parameters, looking at some cross sections, things like that. And you can, again, you can edit these. And if you make your way through this workbook, you'll hopefully then have quite a good feel for the basics of using it and feel a bit more confident in starting to write your own code.